Hey everyone, and welcome to another deep dive with us. This time we're tackling a topic that's out of this world. We're going to be looking at astronaut health during those super long space missions. Like, the ones where they're up there for months at a time, just floating around. I stumbled across this awesome podcast called Space Talks, where astronaut Sunita Williams was chatting about her experiences. And it got me thinking, how do they do it? How do astronauts survive, let alone thrive in space for so long? So today we're going to unpack the science of surviving and thriving among the stars.
It really is mind-blowing what the human body can handle, especially when you think about how different space is from, our normal environment down here. But it takes a lot more than just courage to make it work up there.
So let's break it down. What's the first big obstacle astronauts have to tackle in space?
One of the biggest things is how microgravity messes with your muscles and bones. Basically, without that constant pull of gravity, your muscles and bones start to weaken. Astronauts can actually lose up to 20% of their muscle mass, and their bone density takes a hit too. All this happens after just a few months.
Wait, 20%? So it's like they instantly become couch potatoes, but like in space?
Yeah, you could say that. And the longer they stay up there, the worse it gets. That's why they have to exercise like crazy. Astronauts on the International Space Station have to work out for 2 hours every single day.
2 hours. They must be super dedicated. What kind of workouts do they even do in space?
Well, it's not your usual gym routine, that's for sure. They have all this special equipment that simulates weight training, even though there's no gravity. Like they use bungee cords and harnesses, and there's even this special treadmill that straps them down. The whole point is to target the muscles that get hit hardest by microgravity.
Wow. Sounds like just staying in shape is a full-time job up there. Okay, so what about food? Is it still all like freeze-dried ice cream and Tang like in the old days?
Uh-huh. Not quite. Space food has come a long way since those early missions. It still needs to be practical, but now they really focus on making it nutritious too.
So what are astronauts eating these days? Fill us in.
We'll think of it as gourmet meals made for space. Okay, maybe not gourmet, but definitely a lot tastier than you'd think. They've got tons of freeze-dried and vacuum-sealed options like fruits and veggies and even meat dishes that they just rehydrate.
Sounds like fancy camping food, but with an amazing view. Speaking of essentials, what about water? Is it super limited up there?
Water is obviously crucial whether you're on Earth or in space, but instead of just relying on shipments from Earth, the ISS has this incredible system that recycles almost all the water on board.
Hold on. How do you recycle water in space? That sounds pretty sci-fi to me.
It's really impressive when you think about it. They collect and purify condensation from the air, like moisture from sweat and even breath. And get this, they even recycle urine. It all gets treated and processed until it meets drinking water standards.
Whoa, that's both amazing and a little bit gross. Talk about taking reduce, reuse, recycle to a whole new level. It really makes you appreciate having clean water just readily available here. But let's be real, space is not exactly a walk in the park. What about radiation? I mean, they are outside of Earth's protective atmosphere.
Yeah, that's a big concern. Even though the ISS orbits within Earth's magnetosphere, which helps a bit, astronauts are still exposed to way more radiation than we are down here.
Haha. What do they do about that? Do they wear lead vests or something?
Haha. Nothing like that. The spacecraft itself is built with special shielding to minimize radiation. Plus, astronauts wear dosimeters, these little devices that track how much radiation they're exposed to.
So like a personal radiation tracker. That's pretty cool.
It is, and the data from those dosimeters help scientists figure out the long-term effects of space radiation and come up with ways to protect astronauts better, which is super important for longer missions beyond Earth's magnetic field, like going to Mars.
Yeah, speaking of Mars, radiation's got to be a huge deal breaker for those missions.
It definitely is. Radiation is one of the biggest challenges for deep space travel. Scientists are working on new shielding technologies all the time, and even looking into things like medications that could help the body repair radiation damage.
Wow. So surviving in space is about way more than just dealing with zero gravity. What happens when astronauts finally come back to Earth after floating around for so long?
Well, getting used to Earth's gravity again after a long time in space is no picnic. It's a tough process, both physically and mentally.
I bet. What kinds of challenges do they face?
Well, imagine going from floating effortlessly to suddenly having gravity pull you down again. Muscles that haven't worked against gravity for months are going to be weak. Astronauts often feel dizzy, have trouble with balance, and even just standing up straight can be tough.
Whoa, so it's like they have to learn to walk all over again. How long does it take to get back to normal?
It depends on how long the mission was, but it can take weeks or even months. They do a lot of physical therapy, have supervised exercise programs, and gradually get back to their normal activities to rebuild their strength and coordination.
That's amazing how adaptable the human body is. But it also makes you realize how much we take for granted here on Earth.
Welcome back, everyone. We've only just begun to explore what it takes to survive and thrive in space. So let's dig a little deeper into some of the long-term health challenges astronauts face and the amazing science that's helping them overcome those challenges.
Awesome. I'm ready for more space-age knowledge. Earlier, we talked about muscle and bone loss. But what other long-term effects does microgravity have on the body?
Well, you have to remember that microgravity affects pretty much every system in the body. One area that researchers are really interested in is how it impacts cardiovascular health. You see, without gravity constantly pulling on them, the heart doesn't have to work as hard to pump blood around the body.
So is space like a vacation for your heart then?
Haha. In a way, you could say that. But like with most vacations, there's a downside. If the heart's workload is reduced for too long, it can actually cause the heart muscle to weaken, which could affect how efficiently it works when the astronauts come back to Earth.
So it's use it or lose it, even for our hearts in space.
Emma.
That makes sense. What about vision? Does floating around affect eyesight?
That's a really interesting question. Some astronauts do experience vision changes during and after long space flights. One theory is that without gravity, fluids in the body shift upwards, including fluids in the head. This increased pressure can change the shape of the eyeball, which might lead to vision problems.
Wow, so even our eyes aren't safe from microgravity. It really shows you how interconnected everything is in the body. What are scientists doing to try and counteract these long-term effects? Like, is there any way to create artificial gravity in space?
Artificial gravity is definitely one of the most promising solutions out there. One idea is to rotate a spacecraft or space habitat to create centrifugal force, which would essentially mimic the effects of gravity.
Oh, like that spinning space station in 2001, a space odyssey.
Exactly. While there are some engineering hurdles to overcome, the potential benefits for astronaut health would be huge. Artificial gravity could completely change long-duration space travel and make it way more sustainable for the human body.
That would be a total game changer. It would open up so many possibilities for exploration and even living in space long term. Okay, let's switch gears a bit. We talked about radiation earlier, but that was more about missions closer to Earth. What about missions further out, like a trip to Mars?
Radiation exposure is definitely one of the biggest risks when it comes to deep space travel. The farther away you get from Earth's magnetosphere, the more you're exposed to harmful cosmic rays.
So is the shielding they use on the ISS enough to protect astronauts going to Mars?
The traditional shielding methods, like using thick layers of aluminum or water, can work, but they add a ton of weight to the spacecraft, which makes those longer missions a lot harder to pull off. So scientists are having to get creative and look for new solutions.
Like what? Are we talking force fields yet?
Not quite yet. But we are talking about some super advanced materials science. Researchers are exploring new lightweight materials that can block radiation really effectively.
That sounds like something straight out of Star Trek. What kind of materials are they looking at?
One promising avenue is using composites made with hydrogen-rich compounds because they're great at absorbing radiation. They're also looking into magnetic fields. The idea is that a magnetic field could deflect charged particles, essentially creating an invisible shield around the spacecraft.
That's incredible. It's amazing how science fiction is becoming science fact. Okay, let's talk about another crucial part of deep space missions, sustainable habitats. If we're going to send humans to Mars, or even set up permanent settlements on other planets, we need to figure out how to create living environments that can support human life for the long haul. I mean, there's no such thing as ordering takeout on Mars.
Exactly. Building self-sustaining habitats is a major challenge, but we're making some really exciting progress.
So what are some of the key things to consider when designing these habitats? What are the absolute must-haves for survival?
The goal is to create closed-loop ecosystems that can provide everything humans need to survive and thrive. Breathable air, clean water, nutritious food, and efficient waste recycling systems.
So basically creating a mini Earth on a spaceship or another planet. How close are we to actually achieving this?
Scientists are making big strides with bioregenerative life support systems. These systems use plants and microorganisms to recycle waste, generate oxygen, and even produce food.
So we're learning to harness the power of nature even in the harsh conditions of space.
Precisely. By mimicking natural processes, we can create sustainable environments in even the most extreme places. It's a testament to human ingenuity.
It really is. But what about the mental side of things? Besides the essential life support systems, How do you design a space habitat that takes care of people's mental well-being when they're potentially millions of miles from Earth?
That's a critical part of the design process. It's about creating habitats that feel more like homes than just sterile outposts. Imagine spacious living areas with natural light communal gardens where astronauts can grow their own food in private quarters for relaxation and solitude. The aim is to create a sense of community and connection to nature, even in the vastness of space.
Those sound like some pretty awesome space digs. It's interesting to think about how these designs might even influence architecture here on Earth. Are there any specific projects in the works that you're particularly excited about?
There are a few really innovative projects going on right now. The European Space Agency is developing something called MELISA, which stands for Microecological Life Support System Alternative. It's a super ambitious project that's trying to create a completely closed-loop ecosystem that could sustain human life indefinitely. And then you have private companies like Blue Origin and SpaceX who are working on huge space habitats that could house thousands of people.
It sounds like we're on the verge of a whole new era of space exploration, where humans aren't just visiting space, but actually living and working there long term. But with all these advancements come new challenges and new questions.
Definitely. As we venture further into space and become capable of establishing a permanent human presence off Earth, we need to think carefully about the ethical and philosophical implications of what we're doing.
That's a really important point.
Yeah.
We need to have serious conversations about things like our responsibility to future generations, equitable access to space, and the impact our presence has on other celestial bodies. It's about pushing the boundaries of knowledge and technology, but doing it responsibly and ethically.
Exactly. It's about embracing the wonder and opportunity of space exploration while also understanding the responsibilities that come with it.
Well said. This deep dive has been incredible. It's given me a whole new sense of awe and wonder about space and all the incredible progress we're making in understanding and overcoming the challenges it presents. Welcome back for the last part of our deep dive into astronaut health. We've covered a lot of ground already, like the physical challenges of living in space, muscle loss, radiation, all that
Oh.
stuff. But now I kind of want to shift gears and talk about the mental side of things.
Yeah, that's a really important aspect of space travel that often gets overlooked. We talk about all the cool tech, the habitats, the life support systems, but creating an environment that supports the mental and emotional well-being of astronauts is just as critical.
Yeah, exactly. It's easy to get caught up in the whole science fiction aspect of space travel. But at the end of the day, it's humans up there making these journeys.
Hmm.
So what kind of psychological toll does all this have on them, being in space for so long?
Well, just imagine being stuck in a pretty small space with the same small group of people for months and months, with very limited contact with your family and friends back home. It's like an extreme version of isolation and confinement, and it definitely takes a toll on people mentally.
Yeah, that sounds intense. Almost like a social experiment. So how do astronauts cope with feeling isolated and homesick?
Well, space agencies take psychological well-being very seriously. Astronauts go through a ton of psychological screening and training before they even get to go on a mission. They're taught coping mechanisms for dealing with stress isolation and, all the unique demands of space travel. And while they're up there, they have regular video calls with their families and friends, access to counselors if they need it, and they get time for leisure activities too.
So it's a combination of preparation beforehand and support during the mission.
Hmm.
That makes sense. But beyond all that, what about the psychological impact of just being in such a unique and awe-inspiring environment? Like looking down at Earth from space has to be a pretty profound experience.
Oh, absolutely. A lot of astronauts talk about something called the overview effect. It's this shift in awareness that happens when you see Earth from space. They often describe feeling a sense of awe, interconnectedness, and a really deep appreciation for how fragile our planet is.
Wow, that sounds almost spiritual.
It can be a really moving experience, and it's why psychological support is so important. Astronauts need to be prepared to deal with those intense emotions and integrate them into their overall experience.
I can only imagine. It makes you wonder how easy it is to adjust back to normal life on Earth after going through something like that.
Yeah, coming back to Earth can be tough. Some astronauts experience what's called reverse culture shock. They've been living in this highly structured, goal-oriented environment, and then suddenly they're back in the chaos of everyday life. It can be really overwhelming.
So it's not just the physical rehabilitation they have to go through, but a mental readjustment too.
Exactly. Post-mission support is really crucial. They have debriefings, psychological evaluations, and even media training to help them transition back to life on Earth and share their experiences with the public.
That's amazing. It's incredible how much care and attention goes into supporting these astronauts, from the moment they're selected to long after they come home.
Yeah, it really shows that space travel isn't just about the technology, it's also about human resilience, adaptability, and the profound impact these experiences have on the people who undertake them.
Couldn't have said it better myself. Well, that wraps up our deep dive into astronaut health. It's been an incredible journey exploring not just the science of keeping astronauts healthy in space, but also the psychological and emotional aspects of these amazing missions.
Thanks for joining us. We hope this has inspired you to keep looking up at the stars and wondering what's out there. Who knows, maybe one day you'll be the one venturing out into space and pushing the boundaries of human exploration.
And until then, keep exploring and keep those questions coming. We'll catch you on the next deep dive